Hello everyone, this is Karan Gaikwad. Welcome to the week 2 project for advanced structural mechanics. The project is defining a composite body and then determining its volume. The composite body which I've generated is basically a lamp, which is composed of a hemisphere at the top and then two different radii cylinders at the bottom. Coming to the hemisphere, the variables that I've used to define this hemisphere are the radius, the elevation angle, and the base angle theta. So this is the parameterization that I've used to define the hemisphere. Again, you could see that this is a peculiar thing. I've added +3 to the x3 basically in order to align the shape. So I've defined the surface basically first by keeping the radius constant and then keeping the theta constant at azimuth equal to 0 and then at azimuth equal to t and then keeping the elevation angle phi constant. So in the above screenshot, you can see that I've calculated the Jacobian for the hemisphere, which is basically obtained by taking the differential with respect the cross product of the differentials of the first two variables and then taking the dot product with respect to the differential of the third. And it comes out to be r square sine phi, which I've used over here to calculate the volume for the hemisphere, which you could see in the last slide of this video. Coming to the cylinders, the variables that I've used are again r, which is denoted by a small radius, that is denoted by a small r, and the height. So this is the parameterization for the thin cylinder, uh, and this is the parameterization for the bigger one. So you can see the difference in radius, basically r and 2r. Again, this z minus 6 thing at the end is done in order to align these cylinders beneath the hemisphere. So you could see I've obtained the Jacobian for the cylinders as well, which is basically the same process as we have discussed for the hemisphere. The Jacobian comes out to be R, which I've used both here and here in order to determine the volume. Coming to the volume of the composite object comes out to be 148.172 by hand calculation using the formulas for all these shapes. And the MATLAB volume comes out to be 141.1009. So the error percentage is 4.76, which I guess is within the acceptable limits. Here you could see a screenshot of my MATLAB code. You can pause the video and have a look at it. Also, here is the volume of the body that I've obtained using MATLAB. That's it, folks. Thank you so much for watching. Have a good one.